Hello students, welcome to the topic definite integration. We will continue how to solve the problems using fundamental theorem of integral calculus. This is your first question. Integration goes from 0 to 1 x cube into 1 minus x square, the whole bracket raised to 5 by 2 with respect to x. Let's see the solution. The given integral we will consider as I. It goes from 0 to 1 x cube into 1 minus x square, whole bracket raised to 5 by 2 with respect to x. This x cube, we can write it as x square into x, right? Now, we will consider this 1 minus x square as t, right? So, that x square will become 1 minus t. Let us differentiate 1 minus x square. That becomes minus 2x dx is equal to dt. Therefore, x dx can be written as minus dt by 2. Now, let us change the variable. And t is equal to 1 minus x square. Now, substituting the lower limit, when x is equal to 0, t becomes 1 minus 0. That becomes 1. When x is equal to upper limit, that is 1, t becomes 1 minus 1. That is equal to 0. So, earlier limits are 0 to 1. Now it becomes 1 to 0. So, your original integral I, earlier it goes from 0 to 1. It becomes 1 to 0. And we can write it instead of x square 1 minus t, and instead of 1 minus x square we can write t whole bracket raised to 5 by 2. So it becomes t raised to 5 by 2 into minus dt by 2. Let us solve it further. Here minus taking outside, we can write it 1 to 0, 1 minus t into t raised to 5 by 2 into dt by 2. Now, by applying the property of definite integration, that integration of f of x dx goes from a to b can be written as minus of b to a f of x with respect to dx. So here it becomes 0 to 1, 1 minus t, t raised to 5 by 2 with respect to dt by 2. So let us multiply by this t raised to 5 by 2 inside the bracket, and taking half outside of integral, it becomes 0 to 1 t raised to 5 by 2 minus t raised to 7 by 2 with respect to dt. Let us integrate that. T raised to 5 by 2, it becomes t raised to 7 by 2 upon 7 by 2 minus t raised to 9 by 2 upon 9 by 2, goes from 0 to 1. So substituting the upper limit 1, it becomes inside the bracket 2 by 7 into 1 minus 2 by 9 into 1, whereas lower limit is 0. So the entire bracket becomes 0. Now let us solve it further. 1 by 2 inside the bracket 2 by 7 minus 2 by 9. By cross multiplication we will get 18 minus 14 upon 63. So it becomes 4 upon 63 and half outside. So let us cancel that 2. It will become 2 by 63. This is the answer, right? Now let's see the next sum. Integration goes from 0 to pi by 4 sin 2x upon sin x raised to 4 plus cos x raised to 4 with respect to dx. Let us consider given integral as I. Now, instead of this sin x raised to 4, we can write it sin square x the whole square. Whereas cos x raised to 4, we can write it as cos square x the whole square. Now, in the next step, instead of cos square x, I'll convert it in terms of sine by using the identity. Look at that. That is 1 minus sine square x, right? Now, here we will consider sine square x as t. Differentiate with respect to x, we'll get 2 sin x cos x dx is equal to dt. That is sin 2x into dx with respect to dt. Since we have substituted sin square x as t, let us change the limits. When x is equal to 0, t becomes sin square of 0, that is 0. Now, substitute the upper limit. When x is equal to pi by 4, t is equal to sin square pi by 4, that is sin 45 value is 1 upon root 2, the whole square, so it becomes 1 by 2, right? So, now the limits are 0 and half. So, your original integral I, earlier it is 0 to pi by 4, but now it goes from 0 to half, and it becomes dt upon t square plus 1 minus t the whole square. Let us solve it further. Here it goes from 0 to half. Further, t square will be as it is. Expand that bracket, it becomes 1 minus 2t plus t square, which I can write it as 2t square minus 2t plus 1, right? Now, to solve that, I'll take out the first 2 common from the denominator. It becomes dt upon 2 outside, inside the bracket t square minus t plus 1 by 2. Look at that. Is it a quadratic equation? And we have the method for that. If it is integration of 1 upon ax square plus bx plus c form, then use the completing square method and convert it into formula. So let us solve it. Half into coefficient of x. Here the coefficient of x is what? -1. So half into -1 the whole square, that becomes 1/4. Now let us do that adjustment. dt upon t square minus t, and 1/2 is there. Let us write it before that. Plus 1/4 minus 1/4. Right? Now look at that. Integration. Here half outside, it goes from 0 to half dt upon, in one bracket, t square minus t plus 1/4 plus 1/4. So half outside, it becomes bracket square, which it is t minus half the whole square plus 1/2 the whole square. It is in the form of 1 upon x square plus a square. So the answer is 1/8 tan inverse of x by a. So I can write it 1/2 earlier term, that is outside, and into 1 upon half tan inverse of t minus half upon half, goes from 0 to half. Right? Now let us solve that. 2 will get cancelled. Now here tan inverse of t minus half upon half, I am substituting the upper limit, that is half, and lower limit, that is 0. So it becomes tan inverse of half minus half, that becomes 0, whereas here it becomes minus half upon half, it becomes -1. The next step, the value of tan inverse of 0 is 0, right? Minus the value of tan inverse of -1 is minus pi/4. So it becomes 0 minus of minus pi/4, that becomes pi/4. So this is the final answer. Thank you.